To the Essential Substance Abuse Skills webinar series. I'm Kate Trams, and today we've invited Dr. Ken Winters to speak on the Science of Addiction, the Brain on Adolescence. This training series is brought to you by the National American Indian and Alaska Native Addiction Technology Transfer Center, or ATTC. We are one of 4 national focus centers serving the ATTC network, which also includes 10 regional centers and a network coordinating office. To learn more, please visit our website. This series is designed to be a broad overview to assist in preparing for written alcohol and drug certification exams, to enhance existing knowledge, and to improve overall competence and treatment outcomes. Please be aware that this series is not meant to stand alone, and previous education and training is necessary in order to pass alcohol and drug certification exams. We recommend that if you are preparing for an exam that you seek additional preparatory help and let this course be one of the many tools you use to prepare. Our next webinar in this series is scheduled for April 15, when Dee LeBeau-Hein will present Referral, Service Coordination, and Documentation. We also offer the American Indian and Alaska Native Behavioral Health webinar series on the first Wednesday of each month, and we'll welcome Dr. Andrew Finch of Vanderbilt University on April 1st to discuss recovery schools. For more information on our webinar series, you can contact me at the email address or phone number provided on this slide. Our center is a NADAC certified educational provider, and we'd be happy to provide you with CEHs for a $15 fee. The CEH request form is available for download in the Files pod in the webinar screen, and I will also be sending this form in a follow-up email to all who attended. Immediately following today's webinar, you'll be redirected to our GPRA evaluation. GPRA stands for the Government Performance and Results Act, and SAMHSA asks us to evaluate our events in order to comply with this act and provide improved performance assessment and accountability. This survey asks about your satisfaction with the event and will take less than 10 minutes to complete. We thank you in advance for helping us to improve our programs. If you've never used the Adobe Connect system before, you may view the presentation in full screen mode by clicking on the full screen button at the top right corner of the presentation pod, which looks like 4 arrows pointing outward. To return to the regular view, click the button again. You will be muted for the duration of this webinar. Please use the Q&A pod to share your questions and comments, and we will address questions at appropriate points during the presentation. We would also like you to be aware that this webinar records participant attention time. If you minimize the webinar or are working in another window, the system will record your participation as inactive, which may be reflected in the number of CEHs received. As I mentioned, today's speaker is Dr. Ken Winters. Dr. Winters is the director of the Center for Adolescent Substance Abuse Research and is a professor in the Department of Psychiatry at the University of Minnesota Medical School. He's also a senior scientist at the Treatment Research Institute. He has published numerous articles based on his research in the prevention and treatment of adolescent drug abuse and serves on the editorial boards for a number of journals, including the Psychology of Addictive Behaviors and the Journal of Child and Adolescent Substance Abuse. Dr. Winters, I just want to thank you so much for joining us today, and I'm going to pull up your slides a moment and pass things over to you. So thank you so much, and just want to welcome everybody and look forward to this session.
Excellent. Thank you, Kate, and appreciate the nice introduction. Welcome, everyone. As you can see, my email is there on this opening slide, and so if you have questions that you think of later or don't get a chance to participate in the Q&A at the end, feel free to email me, and even if the email is to set up a small phone chat, if the question you have is a little complicated, we can do that as well. And so I'm a clinical psychologist by training and have studied adolescent drug abuse for quite a while, but I'm not a neuroscientist. Now that might seem like a bad omission, given I'm giving a talk here on brain science. But the good news is I have to give you this talk at a level I can understand it at, so it's probably going to be very reachable for all of you. I don't know if we have many neuroscientists listening in. The bad news is you might have a great question that is beyond my knowledge base, so that's why we'll exchange emails if something like that comes up, because there are surely excellent resources I have in my department to help with some pretty tough questions. And so my talk, while it is focusing on adolescence and brain development, it's also going to have a significant intersection with the topic of addiction. And so I'm actually going to lead off with that, a little primer on the whole overview of some of our understanding of how drugs affect the brain. And then there'll be a second part that's focused just on adolescent brain development, a summary of that science. And then the third big topic is the intersection of the first two. So that's perhaps the most critical topic, because that's looking at what does the science say at this point about when a teenager with a developing brain uses drugs, how much that might contribute to downstream problems, both in terms of risk for addiction as well as perhaps other important impacts on brain development or learning, cognition, memory, etc. And in the summary section, not only will I overview a bit of the brain science, but I'm going to also briefly touch upon what are some of the prevention and treatment implications of this science. I'm hoping there are a lot of clinicians listening in, because I think this information can be used in your clinical practice in engaging teenagers and getting them to rethink about their possible overuse and overindulgence with drugs. So hang in there if you're a clinician, and if you're not too interested in the neuroscience, there's plenty for you coming up. Also, if you want to do more reading on the topic, here are two books I like. One by Anthony Wolfe, the first one on the left. The full title is Get Out of My Life, But First Can You Drive Me and Cheryl to the Mall? It's a pretty clever title, I think, and you'll see soon perhaps how the teen brain is developing in a certain way that might lead to these kinds of outbursts, irrational, over-emotional outbursts by teenagers. And then I've noted here David Walsh's excellent book, Why Do They Act That Way? He's written it for both parents and teenagers. Even though it was written quite a while ago, it is still very relevant. So on to our first major topic. This is my overview of what are some of the basic underlying neurological aspects, brain aspects of addiction. Now, addiction is more than just an impact on the structure and the neural functioning of the brain. There is a very significant, of course, powerful sets of influences that come outside of biology. And so I appreciate that, and I'm not trying to oversell the biological pathways towards addiction with this part of my talk. We don't have time to get into the complexity of that whole issue of how much of it is biology, how much of it is culture, how much is environment, etc. It is a mix. So, and while I'm going to focus on biology for a moment, please appreciate that I'm not selling this as just a biology-only disorder. But science has pointed to some interesting principles that suggest there is a strong biological component when it comes to using and abusing and then perhaps getting dependent on drugs. One of the metaphors I've liked that NIDA has illustrated is the link between, or the similarities, I guess, between eating food, particularly fun food like chocolate, and taking drugs. And two big things are similar. One is that the similar regions of the brain are activated when you enjoy eating chocolate, in addition to when you're taking cocaine and getting the positive impact of that. So similar regions, it's generally called the reward pathway region, but it's part of the brain that also resides sections that have to do with motivation, memory, and emotion. Also, what's happening is that similar chemicals are activated. They contribute to the positive rewards, and the main chemical, and it's referenced here with the yellow balls, is dopamine. Dopamine is a neurotransmitter chemical in the brain. When it's elevated or when it spikes in people, usually you get a positive reaction, a positive feeling. often a positive emotion or even a physical positivity. When you get a depletion of dopamine, you usually get a funk, down in the dumps, a negative type experience. So dopamine's involved in a lot of everyday living. If you hear a good joke, you probably, when you laugh, you're probably also getting a little spike in dopamine. I'll bring it back home. Last week here in Minnesota, we had early spring. It got up to almost, I think, 70 degrees a couple days. It's way early, and I got to believe when people were looking at the weather map or going outside and seeing how warm it was, you had a collective, a whole state of dopamine was getting elevated. But a big difference, and it's represented in this slide on the right, which represents in artist form when the acute effects of cocaine. You can see a lot more dopamine included in that neurotransmitter, in that region where there's a lot of neural activity going on. On the left, where someone is getting a nice little normal positive response to food, you're getting much lower amounts of dopamine. So with food, you're getting a normal, so-called normal, even keel spike in dopamine. When taking cocaine, you get an exaggerated, a very intense amount of dopamine that floods your system. And so, not a news bulletin. You eat chocolate, you feel like that's pretty favorable. You might get a little memory that that's pretty good. You like it, but of course you can move on with your day. But when you take a drug like cocaine, you get a big wow effect, and this can be very powerful. So it's called the hijacking of the brain when this excessive flooding of dopamine occurs. More on that in a moment. Just another slide to represent the basic principle I just noted. So the blue box on top to the right that's labeled with amphetamine, you can see the red lines, and that red line spikes quite acutely very early on and then starts to diminish. That shows the spiking of dopamine in a person that has just taken amphetamines. On the bottom, you can see the red line, how it just shows a minimal type of increase, an uptick that's very small, and that's sort of the normal response to food. Obviously, a huge difference. And another way to look at it is with brain scan. This is a human that was given cocaine, and then his brain is being measured in a brain scan machine while he is high on cocaine. So the more yellow you see shows the more impact cocaine is having on the dopamine neurotransmitter activity. The person's report of how euphoric they feel is pretty much matching when you see the yellow accelerating and increasing, and then when the yellow abates, the person's report of euphoria drops. And so pretty big impact quite early, about the 3rd minute, gets quite intense throughout up until about the 10th minute, and then the effect wears off. Now, I mentioned that a metaphor of drugs hijacking the brain has been used to describe this process. And it's an interesting point because it's more than just that you get a spike in dopamine that causes people to feel high. If that was just the case, if it just stopped there, perhaps there wouldn't be as much addiction among humans, or there wouldn't be as much suffering when people get overindulgent with drugs. But the problem is something happens in the brain if you keep insulting it with drugs that cause this excessive spiking of dopamine. The brain kicks into a compensatory mechanism, and the brain is an organ of the body that, like all other major organs of the human body, have this basic principle. When something is out of kilter, it seeks to bring it back to normal, or it seeks to compensate for whatever exaggeration is occurring and bring it back to normal. So you get a virus, you get a fever. Well, the fever is an effort for your body to fight off the virus. If you exert yourself with exercise, you sweat. Well, the sweating is trying to cool down your body, which has got hot from exercise. You overexcite your brain too frequently or repeatedly with drugs, with that dopamine spiking. Your dopamine system, the factory that's producing it and causing it to work throughout the brain, starts to slow down. It is seeking to correct for what looks like a problem. This is a slide that it's a little complicated, but you can see on the left set of brains, the four that are right above the word control, brain scans, and those are in blue. And then within each of the blue, you see some yellow zones, and then within that, some orange or red. And those are all normal individuals who are not addicted to drugs or have any problem with drugs. And this is just showing 4 different people and what might be a normal brain scan looking at their dopamine functioning, a particular type of functioning or band of dopamine called D2 receptors. And so you can see with all those 4 brain scans above the word control, there's a fair amount of orange or red inside those green yellowish zones. Now to the right are 4 other different people. These people are all addicted to a drug, and you can see if you go far left by reading what row they're in, you can tell what drug they're addicted to. And you'll notice 2 things. They all have the same kind of problem or similar kind of pattern, and that pattern also is similar in that they have much less of the red or orange, which means they have much dopamine D2 receptors working for them. So they have used chemicals enough to cause their dopamine system to compensate. And that compensation has led to a decrement or a lowering in dopamine production. And if you have a drop in dopamine, you will not feel your normal self, in a funk, perhaps depressed. And it's probably the biological basis for then you get urges to use again, because you want to have to address or treat, if you will, this acute form of withdrawal, this hijacking problem. So you get high for a little while, you keep doing it too many times, you get then in this funk, and then you want to use drugs to get out of the funk. The good news is if you can get drug-free, you can get functioning back to normal. On the top row is a non-addicted person just trying to show with this kind of brain scan what normal functioning would look like. So the more yellow here means the more normal active functioning of the brain. The yellow here is not dopamine levels. And the middle and bottom row is the scan of a single person who is 10 days free of cocaine and then 100 days free of cocaine. So you can see improvement in the functioning, more yellow as the person is abstinent for more days. And perhaps if this person stays abstinent for several more weeks or months, there would even be more restoration. So the good news is you get your dopamine system back to normal, but you have to hang in there and fight through urges that are probably going to happen early on, and hang in there as the normal restoration process takes hold. So we'll return to some of those principles in a little bit, but now we have to go to the second major neuroscience topic. This is on adolescent brain development. So we're not going to talk about drugs for the time being. This is just on what we have come to believe as some interesting findings about how the brain is importantly developing during the teenage years. And important principles that you will see are related downstream as we talk about what happens when a teenager with a developing brain starts to use drugs. So some cautions, though, as I lead off this section. This is still emerging science. Some of the studies are based on small samples, and there hasn't been enough science yet, or enough time for the science to give us a broad view of how these principles hold up individuals from very different backgrounds. We're not sure yet about gender or ethnic difference. All these things will get further understood as this science unfolds. So I always call this science it's very early in a ball game. So it might, if you can imagine the science of understanding how cigarette smoke deleteriously impacts the lungs. You might consider that science very mature, long-standing, a lot of studies in terms of how long a ball game lasts. That might be science that's in the 8th inning, I'll say. And this science here with teen brain development, we might really just be in the 2nd inning or the 3rd inning. So a lot to go, but I'm going to give you some basic principles that appear to be still holding up as researchers are looking inside the adolescent brain. One of the principles is that adolescence is a time of significant brain development. Earlier thoughts were that development ended right around the beginning of adolescence, and the biggest biology to worry about or think about when adolescence kicked in was hormonal changes. But now it looks like that's not the case. We have not only hormonal changes to work into the mix, but we also have, looks like, a lot of brain development. The maturation period, roughly for most young people, ends about age 25. So that's a kind of a shocker especially for those scientists who had thought it really was ended by around age 12 or 13. When you think of the age 25, I like to put a little cultural spin on it. So this little sidebar topic. Here's a slide that represents the 3 major ages of majority or privileges in our culture. The 16, very important for driving, although there are some restrictions. And 18 perhaps is the biggest one in our culture, where a young person gets the majority of new privileges and rights, including voting. But in terms of addiction, you have smoking is eligible, and gambling in some instances by 18. And 21 is drinking. And you may know the drinking age is 21 because of the public health movement to try to reduce the highway traffic fatalities with young people driving. Interesting that drinking is 21 and smoking is 18. There is not carnage on the highways with smoking, so we're not getting a political pull to move it up. But the odds are more young people will be addicted to cigarettes or tobacco than they will to alcohol in their lifetime. And the odds are, if they were going to die of an addiction, that smoking or smoking-related disorders or diseases will be the culprit more often than any other substance. I mentioned 16 was a minimum age for driving. It's gotten interesting, though, because it's not as simple as just age 16. When I was growing up, that was it. You hit 16, you could, as long as you passed your test, you were ready to go without restrictions. You may know many states have graduated driver licensing regulations, and these put some clamps on a young person with a car early on in their driving. This is a clever ad, I thought, from Allstate that was published in 2007, and the ad says, "Why do most 16-year-olds drink like they're missing a part of their brain?" And then below it, "Because they are," and they're kind of a nice hyperbole with a big hole there in the shape of a Volkswagen Beetle. And just the text is just a reminder of the value of these graduated driver licensing regulations to help young drivers stay safer on the highways. The location of that hole is pretty relevant. I think they had a neuroscientist help them out with that. You'll see that in a moment. The second principle that has come out of the understanding of teen brain development is represented in this slide. Looks like this kid is having a heck of a good time. He is enjoying a special bungee jump. This is a bungee jump that where you could pay a little extra and you go higher up than the usual place, and you get a bicycle, and then you get to ride the bike down a ramp. And this photo is taken when he's left the ramp. Right about then, he'll let go of the bike, and that'll drop in a net, and he gets to launch himself out into the air, not just straight down. So this is, your extra special excitement. I didn't see any adults in line for this fun-looking, youth-friendly bungee jump. I like it because it does represent the principle that the teen brain is developing in a way that really does like excitement and perhaps thrives it, seeks it a lot more compared to when the brain is more mature, when you're an adult, even if you control for color and all kinds of other environmental factors. The belief is that the way biology is occurring in the brain with given substructures and other region developments, that the brain is very motivated for sensation seeking, risk taking, is not as concerned about possible negative consequences as much as maybe an adult, is perhaps willing to leap before looking, if you will, more likely than an adult. Another way it's been phrased is not as likely to engage in sober second thought. That's supposed to be a nice metaphor if you're a thoughtful person. You engage in sober second thought, you calm down, you consider other options, etc. As a teenager, it can be tougher to do that, is the hypothesis, because the way the brain is developing doesn't accommodate as easily that kind of thinking. So a little bit more about this brain development. One thing that we know is that this overall weight of the brain, though, is pretty much in place by around age 12 or 13. You can see the height of the bars here levels off around 12-ish, and pretty stable throughout the aging process. I guess there's a slight drop in brain weight as you get into your 50s and 60s, but you can see there is a significant end point in the early teen years of one major maturation principle. That's brain weight, but that's really not informative, though, in terms of brain development. There are so many other processes occurring. In this slide, which I see perhaps is not showing up too well on the left side, the labels for my horizontal, my vertical bar isn't looking too good here, but all of these lines represent a different part of brain development. Some of them majors things like how much volume there is in the brain, and some of them some more subtle things like how many receptors. That's the wiring we have in our brain, how that development is going. Well, you can see during adolescence there is significant development going on in both the brown and the purple line. The brown line is synaptic refinement. More on that in a moment, but I want you to keep that principle in mind, that the major type of developmental process that's still occurring during adolescence is something called synaptic refinement. And the purple, which is myelination, that is also still undergoing some development even past the standard adolescent years and well into the mid-20s. So the good news is when this synaptic refinement is complete, then the brain is going to be more efficient and work better. But during this synaptic refinement or pruning process, the brain is still not functioning at full capacity. And here's a time-lapse picture of synaptic refinement or pruning. So as things, this is recycling here, it's representing a synthesis of brain scans from age 5 to 20. As you can see, as the bluing occurs, that's the so-called synaptic refinement. Now that means you're actually, during these years, you're losing a net amount of connections in the brain. All the complicated, dense wiring in the brain, you're actually losing some. But it's good news because things are crowded as the brain is developing in childhood and early adolescence. And the pruning back is believed to be very adaptive, provides for a stronger brain in the long run. You can imagine if you have less clutter, then what's retained has more room to develop and strengthen, and also is not in competition for limited resources with parts of the brain that aren't being used. And there is a belief that this pruning does shed as a function of what's been activated or used or what has not. And so those that have already been active and working well in the teen brain, they aren't going to be pruned. It's the inactive, the excess, so-called excess structures that are pruned back. Now, you can see this bluing or pruning process does not occur equally across all regions of the brain. It's more of an enveloping process. But the major belief is that many of the regions in the middle and back of the brain, they get mature faster than regions in the front. And so to the left in the blue box, I have earlier and later. So earlier means they're getting pruned earlier in these teen years. And these regions have to do with motor coordination, emotion, and motivation, among other things. So a lot of things you need for excitement and having fun and enjoying life, including sports, music, perhaps taking risks. Many of these things that relate to behaviors are associated with structures of the brain that are maturing relatively early in this development process. The main point about what's getting developed later is in yellow, and that's the judgment region, or the frontal part of the brain. Prefrontal cortex is one of the main areas associated with this, and it metaphorically is called the seat of sober second thought. So there's this differential maturation, and it's believed that because of that differential maturing, when a teenager is faced with a decision, they're calling upon their brain in a way that's different than how an adult calls upon the brain to help with their decisions. And because things are differentially mature, you might have one region, the so-called fun Nike region of the brain, dominate over the judgment region. So when they've done brain scans, while the teenager is engaged in decision making, and then compared that to brain scans while an adult is engaged in decision making, they do find basically that the teen brain is calling upon their judgment region, but it looks like it's in competition with a heavy activation from the so-called emotion or Nike region of the brain. So it's not that the judgment region is weak, but it looks like it might be unable to push back or to mitigate the influence of the so-called fun part of the brain. As an adult, you're not getting so much overactivation from that Nike or fun part of the brain, and thus the judgment region is able to, without so much distraction, weigh in and do its job for you. This slide is just another way to summarize some of these principles I've been talking about from a behavioral standpoint. You can see there's 8 principles here, or descriptors. What we've done is taken some of the interesting discussions in the literature from developmental psychologists who've tried to make sense of this brain science, and they've come up with possible behavioral and attitudinal implications of what's going on neurologically. Now, this is all assumptions. You have to keep in mind you can't make a direct connection between brain development and specific behavior, but these are interesting principles. If you read and think about the list, you probably come to the realization that there's nothing all that newsworthy here, because this is just another way to perhaps describe some of the things we've always observed about teenagers. Yeah, they like to be with their friends, They have difficulty controlling emotions. They may take risks and show impulsiveness beyond what is safe, really seek out rewards and excitement, etc. But the list is here because we may be seeing these kinds of things in teenagers because of the way their brain is developing, not just culture or not just parenting. Now, we've taken the list and we've highlighted 2 through 8, and my staff and I did this when we realized that this list was interesting if you looked at it from the perspective of risk for drug use. And sure enough, we thought that many items on this list could be risk factors towards curiosity to use or even continued use to the point of getting into problems with drugs. And so, except for physical activity, we thought these others might have a role in contributing. And more on that list later. I do want to mention risk-taking, though, for a moment, because it's an interesting principle. It's a concept that's very important to human behavior, and I don't want to over-pathologize that teens take unhealthy risk all the time, because that isn't necessarily the case. In fact, risk-taking is very adaptive, and it's perhaps something that should be shaped into a healthy form. Perhaps too little risk in a competitive culture is not very adaptive. Now, the thing about teenagers and risk, though, is not that they misunderstand the nature of risk. It looks like from some interesting studies that their extra risk-taking that they might show during adolescence is heavily influenced by contextual and emotional factors, not lack of understanding of the nature of risk or the potential harm. Interesting example in the arena of driving. So a study that used a simulated driving situation was able to show how teenagers in a certain context might be more risky behind the wheel as opposed to young adults or adults. So if you look at the blue bars, this represents either the percent of risky decisions or percent of number of crashes that occurred during a simulated driving task. You can see all 3 age groups had relatively equal height of the bars, the percent of risky decisions and the number of crashes. Non-statistical difference among the 3 groups, but when all individuals were asked to come back and repeat the task, but to bring a friend with them, you can see that there is one big difference, and that was with the youngest group, the adolescents. Their rate of both these negative driving outcomes were much higher compared to the other 2 groups. So the older drivers were able to handle a peer influence. The younger were not. So just to wrap up this last part of adolescent brain development, a reminder that this is not a period of time where teenagers have compromised brain power. It's not the case that this maturation has anything to do with a deficit in thinking. It really has more to do with how it can influence decision making. And then I also want to remind everyone that some teenagers are good decision makers. They have been all their lives, and they didn't get in trouble during the teen years with falling prey to their so-called risky type brain. There's probably some teenagers who have problems with it, and they may have other risk factors, and so the adolescent period may pose an additional vulnerability. But a reminder that this isn't always a clinical level problem. It can be a lot of angst for parents, but normal amount of risky decision making during the teen years can.
Kylie, please pick up the nearest paging phone for a message. Kylie, pick up the nearest paging phone for a message.
Oh, sorry for the interruption. So for many teenagers, they are handling that brain development just fine. Okay, time to get to the third topic. This is now my opportunity to intersect our first two. So we're going to talk about drug use, addiction, and the developing brain. And I'm going to be doing it within the context of to what extent does brain development have an impact on a young person's vulnerability to the use of substances. I'm going to focus on two substances for our talk today, with a heavy amount of focus on alcohol, but also we'll look at marijuana. But first we're going to talk about alcohol, and there's 4 lines of evidence I'm going to introduce to us that speak to the question, are adolescents more susceptible than adults to alcohol? Now, humans are all susceptible to alcohol. We all have reward pathway systems. We all have dopamine that can fall prey to excessive use. In theory, although humans vary quite a bit on this, but in theory, we all have brains that are potentially susceptible to hijacking by alcohol and other drugs. So we have to actually look at the relative question. Is an adolescent who exposes him or herself to alcohol, do they have a differential vulnerability than adults? Some cautions. This is also still emerging science. A lot of the science is based on animal models. That's always a problem because there can be difficulties generalizing data from animals to humans. I'll remind you of that caution as I point to some of the data soon. We just can't do the human studies like one would hope. It's not ethical to give minors drugs and alcohol, even the legal alcohol, in the lab and look at effects. So I'll remind you how many of the findings are still very cautionary and preliminary. So, but 4 lines of evidence, let me walk you through them pretty quickly, and then I'll sum it up to see where you might think these lines of evidence fall with our main question. Epidemiological studies do suggest that during the teen years, the use of alcohol peaks and on average tends to decrease as you get older. There's several ways to look at it. Here is one that just shows the how early use can portend lifetime risk for dependence on alcohol. There's 3 lines here, and you can see the lines are always decreasing. That means that the later somebody starts drinking, the lower their probability of having a lifetime problem with alcohol. The green and the blue lines represent whether you have family history or not. So if you have family history, you got a little more elevated risk. If you don't have family history, you have a little less. The red line is the total of the sample, but all of the lines show the same trend. Earlier use gives you a greater risk of a lifetime problem. The later you can start using alcohol, the more protection you have from a lifetime problem. So that would suggest that youth is a risk factor when using. Another way it's been looked at is with these data. These show the risk of having a recent problem during your teen years based on how early you use alcohol. So the bars represent percentages of those that have an alcohol use disorder within the last year, based on whether you used alcohol for the first time in your life within the last 2 years. So it's just looking at within each age, and the age is at the bottom. Teenagers, it's said among those that reported for the first time they started to use alcohol, then what percent of them met criteria for an alcohol use disorder. And so the way you read the first bar way to the left, it has at the bottom of the bar it says 12Y. That means among 12-year-olds that were in this national survey, and among those that said they started to use alcohol within the last 2 years of when they took the survey, so roughly while they were age 10 or 11, 7.2% reported enough symptoms, current symptoms, to meet alcohol use disorder criteria. And so you can see how the bars hover between 7 and almost 10 from ages 12 to 18, and then after 18, look how it drops. Bounces around a little bit, but there's a significant drop. Waiting later in the teen years also is protective to the extent that you will or will not have a current problem with alcohol. Principle number 2 is using animal models. As I mentioned, we're not going to be able to give adolescents alcohol in the lab and see how the acute effects might be different than an adult in a lab. But animal models have been done so that adolescent rats are given alcohol and then they're compared to adult rats, and differences or similarities are looked at. Rats, when they get intoxicated, they do actually show behaviors that are fairly, or mimic, I guess the best way to say it, what happens when adults get intoxicated. So they will have motor coordination problems. A rat does when intoxicated. Will get sleepy. Will have a version of acute withdrawal, and even has changes in social behavior. So one thing that was looked at is what were some of the acute effects of intoxication on adolescent and adult rats, and the principle that was discovered was the adolescent rat looks like they're less sensitive to the sedative and motor impairment impact of alcohol. One of the ways this was tested is the water maze test, thanks to Kim Harris for this cartoon. And what's done is rats are put in a little bowl. Rats don't like water, so they're motivated to find a way out of it. And then you put a platform just below the water surface, and the rat finally figures out how to find it. And so you can measure swimming time, how quickly they found the platform, etc. And it turns out an adolescent rat that's intoxicated does a better job in this task than the adult rat that's intoxicated. So other tasks are used, and the basic idea is it suggests less sensitivity, which if we apply that to humans, that might mean that if you're less sensitive to the acute effects of alcohol, that might embolden you to keep on drinking even though you might be intoxicated. And you might be intoxicated past a very healthy point. But if you don't think you're drunk, you're not going to stop. Or you're going to perhaps engage in driving or other risky things because you just don't think that you're impaired. There might be some human data to support it. This is monitoring the future data, comparing 2 data points. In orange is teenagers that are responding yes to the item, had 5 or more drinks in a row in the past 2 weeks. And in yellow, it's percent that report been drunk past month. And you can see among 8th graders, they had a much lower percent that said they felt drunk compared to the percent that said they drank 5 or more. And if you're drinking 5 or more as an 8th grader, what are you, about 14 years, 15 years of age, you probably are drunk. So this might suggest that that this sensitivity issue is coming into play when we're asking teenagers about their experiences. The other thing that's been studied is adolescent rats and their social behavior. So as with humans, alcohol can be a social lubricant, and you can be more talkative, more friendly, want to hang out with people, or rats more, and rats do this. They play fight more. They seek out groups of rats more readily when intoxicated. All age groups of rats do this, but they found with comparative studies that the adolescent rat actually showed more of the behavior. So the principle here is that the adolescent rat might be more sensitive to the effects of alcohol. So you have 2 principles. Adolescent rat, less sensitive to the negative, more sensitive to the positives than the adult rat. So if that applies to humans, it might be that as teenagers are growing up and they're experiencing alcohol, they don't sense the negative very quickly. They feel like they can keep on drinking well past 2 or 3 beverages and not feel like they're drunk. And because they might be enjoying the social rewards of it, at least the social uptick that the alcohol can have, that social disinhibitory effect that makes people feel a little more socially confident and comfortable. All of that might get translated by a teenager as, I really like this feeling and I'm going to keep on doing it. And that could be surely a recipe for problems. And as you may know, the youth years is a high period of time of drinking. Binge drinking is, in America, is actually at its peak during the young adult years, which may have a lot to do with college context. My final one is just to talk about where we are with what impact alcohol might have on memory and learning. It makes sense to look at that because alcohol can do heavy damage to a memory region of the brain called the hippocampus. In rats, if you indulge them in heavy doses of alcohol, you do get decrements in learning, and you get more of a learning deficit among the adolescent rat than the adult rat. That suggests that teenage brain is a little more vulnerable to the toxicity of alcohol than an adult brain. Now with humans, we have very correlational studies. I'm going to show you two. Got to keep in mind, because it's not longitudinal, it's very problematic to at this point make any causal inferences. But one study compared two types of teenagers, and one group had a history of alcohol dependence. They were in recovery, so they weren't intoxicated at the time they took the memory task. And versus a group of teenagers matched on as many variables as made sense, or they tried to match with learning and IQ, etc. But these teenagers did not have any alcohol abuse history. And so both groups were given similar tasks, and you can see that the less memory, about 10% less in the alcohol-dependent group compared to the control group on both verbal and nonverbal learning. Hippocampus size has been measured, and in blue to the left is, you can see the clustering of dots, and that's a group that had a smaller hippocampus. On the right is the control, and while it's more dispersed, on average the control group had 10%, about 10% more volume, or another way of saying is the alcohol disorder sample had about 10% smaller volume. It's worth talking about marijuana because that is getting a lot more research attention, and I'm going to show you just a couple data points. One is just to remind us all that medical marijuana as well as recreational is starting to become more common among states. So all the green states here have some type of medical marijuana law, and then I put red dots where there are states that have already implemented recreational use or have passed it in November and look to be implementing. So it's still a minority of states that have recreational access, but people think that perhaps this is just a growing trend and we'll see more downstream. As you may know, states that have recreational laws, they always say 21 is the minimum age, but that's probably going to lead to an increase in use. Marijuana has to be on our radar screen more than ever before. If you're in treatment programs, it always was on your radar screen, but I think we're going to see it perhaps show up in more public health settings, short of treatment, but maybe more emergency room, more high school dropouts, perhaps, and you're not a safe driver when you're high on marijuana, so you may even see a problem with driving. This slide is very hard to read, but I wanted to show you a table from a recent article in New England Journal of Medicine. The whole article is about the potential adverse health effects of marijuana use, and it covers all age groups. But in this table, they highlight where the major adverse effects of short-term and long-term use of marijuana that's supported by at least a fair amount of research literature. So they just included things in the table that appeared to be a fairly rigorous link of that particular health problem and marijuana use. And I put in the red box 5 of them. They're all under the effects of long-term or heavy use. and they all have an asterisk next to them. That's because these are outcomes that the data shows, even at this early stage, that the effect, this negative health effect, is strongly associated with initial marijuana use early in adolescence. So what are these problems? Addiction, altered brain development, poor educational outcome, cognitive impairment, and diminished life satisfaction. So these are all long-term effects that can occur with anyone who's used marijuana heavily over a course of many, many years. But the data is suggesting that these effects are even stronger if somebody uses earlier in life, during adolescence. Another suggestion, youth vulnerable period. I'm not going to go into detail with this slide. It's pretty noisy. It's got a lot of interesting facets to it. If there's time with Q&A, I can elaborate on it. But the bottom line of the slide is when longitudinal data have been looked at, one study has shown that for those individuals who used marijuana chronically over the course of their adult life, and they started their marijuana use in their teenage years, they on average showed a drop in IQ of 8 points, or half a standard deviation. So this similar to some of the other findings. If it's early use and it's chronic, you may be at high risk for deleterious cognitive functioning and related functioning of memory and judgment. Significant IQ drop. Okay. Let me summarize as well as talk about some of the prevention and treatment implications. So hopefully with my talk you've appreciated that adolescence is an interesting time of biological development that we often can't see. It belies what we do see in our mid-teens that look like they have rounded out in terms of height and weight. But we really think of adolescence now, when you consider brain development, as an extended period into the young adulthood years. Normal adolescence, perhaps heavily influenced by brain development, is characterized by various behaviors that might create angst when you're raising a teenager, might lead to problems in the classroom, and perhaps there are big challenges when you're dealing with an individual in the clinic. But these behaviors are fairly normal, even though we might not like them. And they include irritability, risk-taking, over-emotionality, interest in being more with one's friends and perhaps following the norms of one's friends as opposed to following the rules of one's parents or the rules and regulations of youth-serving systems like schools. So I tried to summarize the underlying biology and how there's this interesting differential maturation going on with the so-called Nike part of the brain, where emotion, motivation, physical activity, motor coordination regions are associated with all of those. They tend to mature faster than the judgment region. And this differential maturation may contribute to types or biases in decision-making by teenagers. And some of that can lead to unhealthy decisions and very dangerous risk-taking. But keep in mind, it might also lead to teenagers willing to try new things and to stretch their talents. And when offered an opportunity to try something new, may take advantage of that. And all of those can be huge pluses during the teen years, and the kind of thing that of course parents want to encourage, but also treatment programs can take advantage of that. I didn't talk too much about, well, why are teenagers more vulnerable? If you do think the data points to that, there's several lines of evidence for the alcohol arena, growing evidence with marijuana. So if it is true that youth are more vulnerable, so what's the reason behind it? Why is that? Is it possible that it has something to do with this? You know, just being a teenager, a normal teenager, leads to tendencies, And these tendencies might increase curiosity to use, as well as continuation of use, because if one doesn't take negative consequences too seriously, you might continue to forge ahead. Your friends are using, you're finding it's fun, etc. So surely there could be something to the fact that, well, just normal adolescence is in the way teenagers think about life and make decisions has a risk component to it. There is some other more layered biology, though, to this story, and that might be how dopamine is developing in the teen brain in a way that might create extra vulnerability. There is a belief that the developing brain has what's called a robust dopamine system, which suggests that dopamine activation is more or is stronger or occurs more acutely in the developing brain than an adult brain. This could mean that hijacking process that I talked about some time back, that might happen more quickly in a teen brain than an adult. So one way that we could look at that kind of risk story is a teenager using a certain amount of drugs compared to an adult. They might get a bigger wow effect, that teenager. The dopamine activation might be stronger in that teenager compared to the adult, and the hijacking type phenomenon that often contributes to the urges and the continued use, that might occur more quickly in the teenager than the adult. And thus, that could all contribute downstream to this higher rate of and vulnerability picture of adolescence and drug use. Then there's also the related topic that maybe early exposure also, because the brain is developing, it's vulnerable to more radical changes that can occur in the brain when there's excessive drug use. And so this may alter the sensitivity to the drug, and this sensitivity, which may be in the unfortunate positive direction for the user, because they're getting the positive feelings and acute reactions to it, that may again basically bumps up the reward phenomenon and increases likelihood to use. All of this could be a principle that, while it's likely to have an impact on humans in general, because many of us have a sensitivity to drugs that can contribute to extra vulnerability. Just the teenage years itself with that developing brain may add another layer of sensitivity. So let me talk about the final major topic, and that is just how some of this can be helpful to understanding ways to adjust and inform your prevention and treatment efforts and programs. So on a basic level, and I'm probably preaching the choir here, hopefully you can see that this brain development science does reinforce the importance of both prevention and treatment. Prevention to hopefully reduce the amount of teenagers that will use, or at minimum at least convince the youngest teenagers not to use in the younger years, and perhaps delay the onset of use for some. That can be a favorable health outcome, just delaying the onset of use. Treatment, of course, is vital. If use has gotten to an abusive dependent level, then there has to be a halting of use, a cessation of it, so that the dopamine system can try to repair itself, and the teenager learn how to fight through urges and not get those triggers to be the best of them. We think there's value in teaching teenagers about the science underlying addiction. I think understanding how the brain can be impacted by drugs, that it's not that easy once a pattern and a habit gets started to walk away, and that there is a vulnerability component to doing all this during the teen years. I think many teenagers think that it's relatively simple to turn on and off drug use, and they'll grow out of it. It won't be a problem. It's just a phase in their life, and a pattern that is not going to have any negative consequences to it. Easy, for humans to have that point of view, and it may even be something that's more common among teenagers who are really looking, at and thinking about their current lifestyle, and it might be pretty tough to think downstream and think of the bigger picture. But I think if an understanding of the neurobiology can open eyes up for teens. So we talk to them about how drug use impacts the brain in ways that are similar to how the brain reacts to food, but that it has an important difference, and that important difference can lead to problems. And in other words, it's not just simply a willpower issue, is it? It has more to do than a decision for a person to decide, I think I won't do this anymore, and I'm just going to walk away. It's not that simple. We also talk to teenagers about the implications of heavy use on their current functioning, particularly memory and learning. So if it's true that alcohol abuse may at least temporarily cause a 10% decrement in memory functioning, we ask teenagers to walk through what would that be like for them if they remember 10% less of things they want to remember. That can, at least socially, that can have some big impacts on teenagers. We like to show them the marijuana data because it's an interesting chance for them to get in discussion about what does the data say or not say. That can be helpful. We also think this science has interesting implications for what to make sure you focus on in your prevention and treatment programs. I think a lot of the evidence-based programs in the prevention and treatment arena do a good job of teaching important skills to teenagers. We really emphasize the value of honing in on the skills related to decision making and how to engage in sober second thought. I've got up here 5 ways that could be looked at. They're all pretty much similar, just different ways of saying the same thing. Getting better at impulse control, delaying gratification. And the bottom one is, not trying to stifle good risk-taking or risk-taking in a teenager, but try to shape it towards good risk-taking. For those interested in taking these kind of lessons and educating others, I've got some resources for you. And maybe you'll find this PowerPoint file helpful, but there's also some good stuff out there. For those that have an opportunity to teach kids in a classroom, there are 2 that I know of. BSCS has come out with a very comprehensive classroom program, multimedia based. I think this is 10 lessons, and each of the lessons takes a full hour. Hazelden's published also a multimedia resource. These are 8 mini lessons. Each lesson is about 10 minutes. So might be easier for some schools to use that may have difficulty inserting a new program within an existing curriculum. But these are both user-friendly, and you don't have to be a neuroscientist or an addiction expert to use them, because both of them have great manuals to help teachers implement the lessons. I don't know if any of you have an opportunity to teach parents about this, or if you want to point parents to some existing resources, but I think you can appreciate that this information is of great value to parents, even if it's just parents training, raising a regular teenager. One really good site is Mentor Foundation's Prevention Smart Parents. There's the website. It has several lessons. They're all guided, can be self-administered, or it could be used for a given class. And then perhaps the Cadillac of parent resources comes from Partnership for Drug-Free Kids. Their website is drugfree.org, and they've got multiple layers of resources. And one major section is on teen brain development. We use this website a lot in our parent talks, and we go online and show some of the mini clips and walk them through some of the excellent resources there. Feel free to use this slide if you'd like with parents. This is one of our big summary slides. P-A-R-E-N-T. Each letter stands for a principle that's important for them. And some of the principles have to do with brain development, some with trying to be a good parent at home to promote healthy behaviors and to in the hopes of raising a drug-free child. One of the ones we like to spend time talking about is the letter R. Reinforce their seeking advice from adults. Teach decision making. So we remind parents that it's more than just setting rules and reminding the teenager to abide by the rules. Teenagers often know the rules. That the difficult thing often can be sticking to the rule in the throes of a difficult situation where there might be a lot of emotionality, they're with their friends, etc. So that means kids need to have some outs, ways to handle tough situations, how they can use parents as an ally, how they can use a cell phone, how they can say no in situations. All these things are important life skills, and we encourage parents to think about how they can play a very active role in teaching these skills. The letter T at the bottom is also a good conversation with parents. Tolerate the oops behaviors due to an immature brain. So we get in discussion with parents about, so what are the kinds of things that frustrate you about your teenager, but it's probably not something serious, even though you might think it's hurtful or it might stress you out or might shock you even, but it might be more to do to that developing brain than due to anything really clinical or worthy of a major consequence. And so it's always an interesting discussion where parents fall on that. Oops behavior can be the kind of thing where there's a lot of emotionality. Perhaps a teenager is telling a white lie, perhaps teasing a sibling, etc. And then we get in discussions about making sure you modulate consequences for the serious stuff, and you pull back on things that perhaps are not worthy of that kind of heavy dose of discipline. And here's a slide of some suggested readings. The one at the bottom from Volkoff et al. That's the article I mentioned, the New England Journal of Medicine. It's, I think, a very good contemporary piece that summarizes the current marijuana health effects literature. Okay, that represents the bulk of my talk. I think we've got some time for questions and discussion.
Great, thank you so much, Dr. Winters. It was a wonderful presentation, and thank you everyone for being with us. Please submit questions in the Q&A pod, and we'll address those as they come in. A couple people have already written in about wondering about some of the parenting resources that Dr. Winters was just sharing. So these slides will be available as handouts. You can actually download them right now in the Files pod in the lower left-hand corner of the screen, or we will also be attaching them in our follow-up email, which will come tomorrow. So those will all be included.
I'll just add one thing about the one parent slide, the PARENT. One way we use that is we break the parents off into groups, and each mini group has to take a letter, and they're supposed to come up with 2 or 3 things that a parent can do that's a healthy way to abide by or to support the principle in the letter. And then then it can lead to a nice group discussion when they all come back together and each report on what they talked about with their letter.
All right, while we're waiting for questions to come in, I am going to go back to just my ending slides for a moment. I'll come back to this slide so people can reference Dr. Winter's email again if needed. But while we are waiting a second, I will just go through a couple final things real quickly. As I mentioned, we will be sending out a follow-up email to everyone who registered for the webinar today. It will include a link to the recording if you wish to view this webinar again or wish to share it with anyone who might have missed it. It will also include a link to the survey in case you aren't redirected to it when we finish out here. And also a CEH request form and handouts for the presentation. And just to remind you again, I'll put up our upcoming webinars on the screen right now so you can mark those on your calendar. As always, we welcome suggestions if you have preferences or interest in certain topics. This series is a fixed topic that we offer each year, but our American Indian and Alaska Native Behavioral Health series is always changing, and we are always looking for new presenters and new topics to cover. So we appreciate any feedback and information on that. And yeah, that is all the information that I have for you. I'm going to go back to Dr. Winter's slide so you can write down his contact information as needed.
Kate, let me mention one other thing. One of the themes that comes up a lot when we talk to parents and teenagers is how to deal with facts or myths about marijuana and marijuana use. And so, there's probably a lot of myths in not just in teenagers, but in our culture about this very complex drug. If people are interested, just send me an email. We've, with the help of some great folks at the Children's Hospital in Boston, come up with, I think there's 15 or so-called marijuana facts or myths, and then there's whether it's a myth or a fact is indicated on the sheet, and then a little background. And it can be something as for good discussion point for teens and parents, so they perhaps increase the marijuana IQ of your community.
Great. And we have a question from Amy. She says, this is a fantastic webinar. Any youth-driven campaigns that are effective?
Prevention campaigns?
I'm guessing that might be what she's talking about, but I thought it'd be, yes, she says yes.
Yeah. So yeah. There are a lot of good ones. I always remind people you can get a pretty good summary of good ones if you go to the famous NREP website. So that stands for National Registry of Evidence-Based Programs and Practices. The website is nrepp.samhsa.gov, and then just on that website you can put in what you're looking for, prevention, treatment, whatever, and what age group. But the bottom line is there are a lot of good ones. The ones I like, and I think the data suggests they're the strongest, are the ones that are not just one-shot programs. They have developmental versions that can be applied from middle school throughout high school, and they also are more than just education. I go back to that one slide where I was talking about the value of making sure you teach kids these important life skills that can challenge them in the teen years, and the good programs seem to do that. And they use role playing and peer-led components, etc., to engage kids. But you can't just provide teenagers with the facts about the dangers of drug use. It looks like that just isn't enough for most teenagers.
Great, and I'll just add really quickly that as far as uh, programs that are working with recovery, Dr. Winters and his wife Kate Winters have been doing a wonderful job for us of putting together information on successful programs that are working for our newsletter. Our one that was published in November includes a number of programs, and then we also have one planned to come out in the next few weeks or so that will include additional programs. So I just wanted to mention that as well. We also have a question from Sadie. She asks, what about resources about learning the basics of brain development in children and adolescents?
Oh, so excellent. And from my slideshow, I always reflect back. There's the two I like. So if you like to read, I would get David Walsh's book, Why Do They Act That Way? And then if you like the web, I'd go to drugfree.org, and all you have to do is put in the search window teen brain development, and they've done a nice job with multimedia components of educating all age groups. And it's not just the superficial stuff. They do a nice job of getting into some of the interesting neuroscience. By the way, if you Google teen brain development in Amazon, you're going to find a lot of books. I haven't been able to read enough of them to know which ones are rising to the top, and I still think David Walsh's, even though it's perhaps 10 years old, it probably is still the best. There you go. Now, thanks, Kate. You put up the slide. Yeah, I don't want to leave Anthony Wolf out. I also like his. But those are good.
Sorry, and Dr. Winters, you mentioned a website too. What was that again?
Sure. Drugfree, all one word, .org. And then it's a complex website for parent resources, but if you just put in the search window teen brain development, then it'll send you to the portion of the website that focuses on that.
Great. I'm just sharing that link with people. Then we have another question from Maria. The legalization of marijuana will make it more difficult for parents to dissuade their teens from using because teens will say it's legal and therefore not harmful to them.
Correct. It's a huge problem, and I can't emphasize enough that I'm so surprised that America is going this direction. Which is, I feel free to ask, have me send you my myths document it's really Boston Children's Hospital's document. And I tell parents, you learn this so when you get thrown a curveball by your teenager, you at least can come back with a rational response. We're learning more about why this is not a safe drug. I mean, we're not learning more about why it's medicine. We're learning more about why it's not safe. Just as a sidebar, you may know there is a medical component to marijuana. It's one of the 300 elements in marijuana. Probably only one has the pain relief value or the medical value. The initials are CBD, one element. So when people are smoking marijuana thinking they get medicine, they're 299 elements are not related to the medicine, and of course THC, the other element of interest, gets you high. That's not related to the medicine, at least for those that are taken for legitimate medical purposes, or those that believe it has legitimate medical purposes. So maybe soon we'll be able to extract the CBD, turn it into a medical pill. I know they're working on that. So, but parents and counselors were challenged by it, and so feel free to send me a request if you think my myths document from Boston Children's will be of value. I'll give you one more website. There's been a group that has tried to be the forefront of raising America's awareness about marijuana, and they're not a prohibitionist group. They think there could be some value in figuring out a way to extract the medical part of it or the medicine out of it for legitimate medical purposes. But they think, you know, many states have just gone very irrational in their medical marijuana laws. But anyway, this group is called SAM, but you don't find it by simple web of SAM. You got to go to, the website is all one word, learnaboutsam.org. SAM is an acronym for Smart Approaches to Marijuana. A wonderful website. Kevin Sabat and his group, they have all kinds of resources that are that you can download. If you want to give a talk about marijuana, I just tell people, go to Learn About SAM, download one of their user-friendly PowerPoint files, and you'll be able to rock and roll. So hopefully, you know, we'll get smart. You know, some of these trends happen, right, with public health issues. We romanticize or feel like something new and different is better, and then there's voters' remorse, there's pushback, you know, and then we get smart. But the danger is always to get things repealed is problematic. So a state passes a law, whoa, you know, it's really hard to repeal laws. Yeah, throughout history, it's been very rare. We'll see.
Okay, it looks like we have one more question. Charles is asking, how does geography play a part in this, and is it different in the South versus Midwest youth?
Well, you know, that's a great question. There is geography differences all over the place, and then at one level there's not big differences. So I know this is kind of a view at 10,000 feet, but when you look at youth rates of using alcohol, tobacco, or other drugs, and then you look at the regions of the country, they tend to be pretty similar, except with a little bit more use on the east and west coasts. But then when you get into, you know, other more detailed geographical views of things, you can get some big differences. I mean, there's pockets of the United States that still has a terrible meth problem, but other parts of the country don't. And then some regions have you know, cheap heroin, so then you get heroin problems, etc. The marijuana thing is getting geographical. I'll just put another marijuana spin on your question. I'm not sure you meant just marijuana with it, but so the states that have legalized it, at least for a significant amount of time, and now we've got Colorado and the state of Washington, both have had legal for recreational 21 age up. For Colorado for I think 2 years, and Washington for just about a year come this April. They are seeing increases in use across all ages. Although it's still early to know how much that's related to the change in law, but and often you have to, you know, you can't figure out geographical things until a trend is or something has been in place for a long time. But that's one geographical phenomenon that people are getting worried about. If you legalize it, you're going to get, you know, the rate will go up.
Okay, and then Charles had made a comment about CBD, cognitive behavioral therapy. So someone was asking what that stood for. I think that takes care of all of our questions. So I just wanted to thank you, Dr. Winters, for joining us and for presenting on adolescent brain development today. And did you have any final thoughts you'd want to share?
You know, Amy asked about CBD. Mm-hmm. Wait, and that's CBD is, yeah, mm-hmm. That's an element in marijuana, and it's, I'm not sure I'm going to pronounce it right, cannabinoids, I believe is the pronunciation. So I didn't say CBT, that would be cognitive behavioral therapy. But you might, if you stay on top of the medical marijuana story, you're probably going to hear a lot more about CBDs. because that looks to be, you know, the good stuff in marijuana that is providing people with legitimate pain relief. They're just, unfortunately, the delivery of it is, you know, all confounded by the other stuff.
Thank you. Thank you for noticing my error there.
That's all right. I didn't want people to think you can't go out and say I'm doing CBD therapy. That could be a problem.
Great. Yeah, well, thank you again, Dr. Winters, and thank you everyone for joining us. And at this point, we will go ahead and close out, and just hope you all have a great day.
Thank you all. Thanks, Kate.